I want to thank organizers for inviting me to this important conference. And you know, Gordon Savin's birthday is public holiday in Croatia, 5th of August. It became after he left Croatia. Okay. Gordon started his study of mathematics in Zagreb in 1989. He was 19. He came from army. He just completed his army service. Very young. He spent 3 years in Zagreb. The study shortest time is 4 years, and he did much faster, and he was the best student. And it took me a very short time to notice this very gifted, bright guy with very, very fast brain. He became part of our graduate representation theory. In that time, I was there, Mirko Primc, Ivan Mirković, and some other people. He was very active and he was excellent there. So topics which this undergraduate guy covered on our seminars were Shintani lifting or work proof of rationality of zeta function of curve of finite fields. But probably the best was his thesis, which was spectral decomposition of SL2R mod gamma. So in principle, this would be excellent master's degree thesis. So after that, he went to Harvard, continued to work with Kazhdan and Bernstein, did spectacular PhD, I think 14 pages long, limit multiplicities, and you know the rest. Okay, continue with Kazhdan doing minimal representation and so on. In any way, he was very exceptional, and it's not surprised that he's doing exceptional groups. We common people must satisfy with something more ordinary, like classical groups, sorry. In any case, in Gordon and my life in the last 4 decades happened a number of, let's say, surprising, unexpected things, but somehow we stayed quite close all these 4 decades and good friends, and I hope we'll stay, I'm sure we'll stay also the rest. Okay. Now I will talk about unitarizability. So it's not going to be about theta correspondences and so on, but let me just say that there are connections, and Petar Bakic, who was supposed to talk, maybe he would tell something about unitarity, but his talk was cancelled. Let me just note that Shahidi proved that Caspar reducibilities for classical groups can be 0, 1, half, and 1 exponents. I will come later to this. You can have non-Caspar reducibilities, and I learned for them from McGlenn. He gave me example using theta correspondences. Then Mark Reeder gave me another example. He was using his computations of Hecke algebras. Gordon's first paper was on Hecke algebras, and he's all the time coming back to Hecke algebras. Okay, now I will go to, okay, so it's an approach to unitarizability problem in the case of classical p-adic groups. So I will start with some observation about general linear groups. Last 2 decades of 20th century somehow have seen some fundamental progress for general linear groups, which started in my, just to mention, maybe in my opinion, some most important like Bernstein-Zalewinsky theory. Then you have Bushnell-Kutzko classification, construction of Caspidals. Then you have Harris-Taylor and Enyart proof of local lengths for GLN. So somehow this happens, but there are a number of other important things. So one thing what was surprising is that pretty early in 1984, I completed classification of unitarizability. So it was much before, let's say, construction of Caspidals and so on. And it was surprising because, for example, in p-adic groups, in real groups, people were working for a long time on that problem. And there was no classification of non-unitary duals for at least for 10 years before, and not only for GLN, but for all reductive groups and so on. I will recall a very simple result from the beginning of Bernstein-Zalewinsky. For this, I will use well-known notation of this cross of Bernstein-Zalewinsky for parabolic induction. I will not recall because I think that it was also used before in this conference. Also, we will denote by new character absolute value of determinant. Absolute value is normalized. Now, if you fix irreducible Caspidal GL representations, rho and rho prime, then this result of Bernstein-Zalewinsky is that the rho time rho prime is reducible if and only if rho prime is equivalent to nu to plus minus 1 rho. Okay, so this implies that we have a complementary series nu to alpha rho times nu to alpha rho minus alpha for alpha greater than 0, less than 1/2. Okay, so actually you can have this complementary series same length if you take discrete series delta, but also you can have the same complementary series if you take pi, where pi is Spe representation. Okay, so we know some unitary representation. Actually, Spe you can get globally, unitarizability, but you can also get locally starting ends of complementary series. Okay, now what is we can simply describe unitary dual. So it's product of some collection of Spe and complementary series from Spe, and you have unicity up to permutation. So something very simple. Okay, the same classification hold for real groups and complex and so on. One final remark about this classification is that this is old, so it's now 37 years or something, 38. 3 decades after this, Lapid and Minguez that one can get this classification only knowing this fact, which I wrote already, that reducibility is if and only if rho prime is nu to plus minus one row. This and the representation theory of general reductive groups, which existed already in 1970s years. So actually what they proved that spare representations are saturated, what they called it's very simple property, and from this you can get classification. Actually, this also, the result motivated me to think about this approach, which I will now just describe. So you get everything from this, knowing this exponent. So we will consider groups SP. So now we go to classical groups. So here I will think about SP2N, F, and SO 2N plus 1F. And F will be p-adic characteristic 0. Actually, what we are using doesn't need characteristic, but when we need some result, so they are proved for characteristic 0. Okay, so like Bernstein-Zelevinsky, you have a product of two GL representations. Here, Levy subgroups are isomorphic to direct product of GL and small classical group. So in this way, you can parabolic induction denote this way, like so pi is GL representation, and this is classical group representation. Okay, I think I'll not go to details, but just it's completely analogous. So now I said, last 2 decades of last century were somehow GL, very important for GL, and in this first 2 decades of this century, we have some very important results for classical groups. Probably most important is Arthur endoscopic classification. But interesting for the difference of last 2 decades and GL decades in the last century with unitarity, we have some results. There is a classification of unitary duals with which was did by Lapid, Mujic, and myself. Then unramified done by Mujic and me. But in general, we are really very far from even let's say getting what would be the final the answer. Okay, so let me just, situation here is much more complicated. Unitary parabolic induction is not irreducible, neither tempered. Discrete series are much more complicated. But there is also one fundamental difference, is that for any alpha integer or half integer, you can, okay, so in the rest, we will always write for rho will be irreducible Caspel GL representation, and we will assume that it's self-dual, and also sigma will be irreducible Caspel representation of classical group. And then if we will have rho I will always also be irreducible Caspel G representations when you use, but we will not assume being self-dual. Okay, so the fact which follows, for example, from Arthur and Meglen, that for any alpha, you can find rho and sigma such that nu to alpha rho times sigma reduces. So it means that you have complementary series nu to x rho times sigma, where, okay, this one. So, and so you can have a length 1/2, 1 3/2, and so on. So you have infinitely possibilities for the rest, for the difference of GL case. Several years ago, I proposed strategy of approach to unitarizability based on this reducibility point. So actually, what often I will write this alpha as alpha rho sigma to know, just to stress that this reducibility point, reducibility exponent for these two representations, but also I will use this only alpha just to have a shorter notation. So I will now be a little bit more specific about this strategy. Let me just say that you can read this exponents from Arthur classification of, let's say, tempered representations, among which McGlenn find description which of them are Caspitals and so on. And this is what she calls basic assumption. It was basic assumption before it just, now it's simple formula. So we have first reduction to weakly real case. Okay, so this is something easy. So first, if you have essential delta essentially square integrable, then there exists unique real number and unitarizable delta u such that delta is isomorphic nu to E delta du. So this in this way we define this delta, this, let's say, unitary part. Now we have definition. An irreducible representation pi of classical groups will be called weakly real if pi embeds into rho 1 times rho L sigma such that all rho I are okay, so unitary parts are self-dual. Okay. I think, okay. I hope I will not. I'll say something too wrong. I'm trying to simplify things. Okay, why the weakly real? Because if you are in the case of characters, so this means that these are real valued characters. So this now it's a very simple result tells you that if you have a pi unitarizable, irreducible unitary of classical group, then there exists tau irreducible unitary GL representation and pi prime irreducible unitary weakly real such that pi is isomorphic to what was it, tau time prime. So in this way, since you know classification of GL unitary representations, this reduced classification to weakly real. Actually, you can make more explicit this reduction. Now, a following step is Yansen decomposition. Okay, now in the rest we will always think only of weakly real representations. Fix rho as above, so it means self-dual. And okay, pi weakly real, irreducible representation of Caspel group. Then there exists, so I am just recalling the result of Yansen. There exists irreducible GL representation pi prime and irreducible representation pi rho of classical group, satisfying following conditions. First, pi embeds into pi prime pi rho, then to pi prime embeds into rho 1 times rho L, such that all rho I unitary parts are different from rho. And last is third is that pi rho embeds into rho 1 prime times rho S prime times sigma, and all rho I prime U now are isomorphic to rho. Okay, this. And actually, this guy doesn't need to be uniquely determined by pi, but pi rho is uniquely determined by pi. So for pi non-cuspidal, denote by rho 1 to rho L, all rho such rho as above, such that pi rho is not cuspidal. Then Yansen decomposition is, I will not now define domain and codomain, but let's say you have by ejection pi and pi rho 1 to pi rho L. Okay. It can be made more precisely. So I'm just saying, in the case of GL groups, this is something what is well known and almost trivial. So it's that when you take a GL representation, you can write as product of representations supported in different cuspidal lines. And then it's a triviality that for GL, that this represent, like, let's say there you have what I say, pi is equal, okay, pi 1 times pi l, and then there is triviality. You have already this in Bernstein that so he's working with unitarity in lines. So this is unitary if and only if each of these guys is unitary. Okay, so here's I put it as conjecture. Pi is unitary if and only if all pi I are unitary. Support for this conjecture is not very big, so support is unitary generic representation, then unramified unitary representations, and representations in coranks up to 3. So this is, and also some very isolated additional cases. Okay, now we come to unitarizability in cuspidal lines. Okay, so these are representations for which pi is equal pi rho. So when you start with unitarizability, certainly this is a simple case to start with, and it's natural to start with. But if we are lucky and this conjecture turned to be true, then we will have this will solve complete unitarizability. Okay, so now with this you have this reducibility point alpha rho sigma, which will I simply denote by alpha. My further conjecture is that that unitarizability here depends only on alpha of this reducibility point, not on rho and sigma itself. It's not that easy to formulate precisely this conjecture, because you need to have to use full classification of tempered representations, which is technically pretty complicated, but on examples which I will give, you will understand what I mean by this. So I will just illustrate this kind of independence. Let's say proposition A, all right? Let pi be an irreducible subquotient of nu to x rho times nu to y rho times sigma. Whereas 0 less than x less than y, we can always choose this. Then pi is unitarizable if and only if first case alpha is greater than 0, pi is square integral, or it's Aubert dual, or subquotient of, okay, so of this representation with x plus y less than or equal 1, or x plus 1 less than y less than alpha, if alpha is greater than or equal 1, B is xy less than 1/2 if alpha is equal 1/2. And 2 is alpha equals 0. Pi is subquotient of star with x plus y less than or equal 1. Okay, so I'm just saying if you see this rho and sigma doesn't play any role, actually this also score integrable or bare, there also doesn't play any role. So now let me just okay, so this is all the result. First, various people were doing various cases, starting with Francois Rodier, who did unramified case. But even in already from Rodier, but I said number of people were doing this. Marcella was doing some case, I do not remember which was a reducibility, this may be alpha equal 2 or something. So I'm just, this all the result with a number of people doing. So, okay, so there's something, and actually it's easy if you know reducibility, if you understand the reducibility, which can be quite hard. So when considering, let's say, such things, crucial critical points. So points are critical points are points of highest reducibility. So when maximum number of reducibility hyperplanes intersect. Okay, I will illustrate this on this what I said. Rodier, old result from beginning of 1980s, in which rho was trivial representation, and sigma was trivial representation of SP0. Okay. Oh, maybe he was doing it for GSP4, but I think he has also SP4, but it's directly connected. So, so in this case, alpha is equal to 1. And so if you look now at parameters, okay, his coordinate lines, and you have a then you have this and this. So these are, okay, you have also more of them, but okay. So what is here? So his place where you have trivial and Steinberg plus 2 non-unitary representations. Okay, so this is all the Kasselman result. Okay, so this 2 points will tell you everything. So here, so in the reducibility lines, you have length 2, but here is in intersection you have a length 4. But what is here and what is not trivial to show is that you have length 2. Actually, Rodier proved this using Kasselman, the asymptotics plus McDonald's formulas for spherical functions. So it means even in this case, it's not easy. So what is one interesting thing, what is good to notice for In other cases, is that, let's say, when you are in plane, just when you pass over these lines, you'll get reducibility. But in this case, if you pass over this line, you do not get reducibility. So it means that you can transport information of unitarity here or non-unitarity from here to here. Okay, so in this way, just using this Castleman non-unitarity, you conclude that all these two lines are non-unitary. Okay, so from this follows that here is non-unitary. Here is non-unitary and here is non-unitary. And here you have unitary because you have induced complementary GL2 complementary series. I'm just saying it's trivial situation, but what is crucial is to know what is happening in these two critical points. So, and also we were lucky. We had Castleman result on non-unitarity. Also, unitarity was obvious, trivial, and Steinberg. So this is usually we are far from this situation. Is there some question? So,
critical point in the center.
Oh, here. So this is a representation. Okay, so you can take, let's see, trivial representation of SP2 is irreducible. So this is what happens. So it means that when you pass, let's say, with this exponent, okay, t, so you have whole. So I'm just saying, although this is a reducibility line, passing over this line, you can transport information. And this is a principle which is very important, that these extensions, somehow using this, you can conclude unitarizability very well. So now we will become. So in the case, we will define now critical points, and then I will tell something. Definition: an irreducible representation pi of classical group will be called critical if there exists rho and sigma and x1 to xn real numbers such that pi is subquotient of nu to x1 rho times nu to xn rho times sigma such that the set nu to, okay, so let me see, x1, x2, and so on, xn. So the set is a Z segment containing a reducibility point, so alpha rho sigma. So you can have, they do not need to be different, so they need to be Z connected and contain this. Okay, so now just as usual with unitarity is you go a little bit further, you get much more problems. For just what I said, rank 2 was first, so this was Rodier in beginning of 1980s, and I just said things look trivial, but his papers, I do not remember, 25 or 30 pages, because if you want to write all this really clean, it takes some time. Okay, and just what I said, until that, a number of people were doing rank 2 groups, but just rank 3 didn't. Just for some reason I started, and it will just, I thought it was, as usual, I start something, I think it will be a relatively short work, not short, but let's say 6 months, but it turned out much longer. Okay, so in the case of, so here it means you have, okay, here you have 4, 2, and I think here 2. Okay, so you have about 10 representations. We can count easily in this way, define critical points. But in the case of rank 3, you have, yesterday I counted, you have 111. So this is, you have many more of these representations. So, and now we are coming, so what is crucial is to know unitarizability in these points. So we do not have Castleman result. There are some generalizations done by Marcella and Yansen and so of this, but you do not have something so for all points. So I will, there are, you have for non-unitarizability, so okay. I will now tell something about unitarizability at critical points. So you have standard ways of getting unitary representations. These are discrete series. Then you have overuse of discrete series, like let's say trivial representation. Then you have complementary series. Then you have ends of complementary series. Here, not very, these are nice constructions, but usually you cannot go to the most interesting representation by these constructions, namely only these representations can produce isolated representations in unitary dual. For example, all Speer representations are unitary, and very few of them only on the end parameters. When one of these two parameters is one of this. Okay, so I just told that you have this something like this critical points, and I think you have 69 of this unitary. Actually, when you go with rank further, you'll have less and less unitary and more non-unitary, and you have 42 non-unitary. So for all but one, so you get unitarity from this. Okay, so another which is out of this story is you get for alpha reducibility point greater than 3/2, and this is a representation pi, which is SOCL of nu to minus alpha rho, nu to minus alpha plus 1 rho, cross SOCL of nu to alpha rho times sigma. Okay, for this representation, Meglan, so this representation is not here. It is isolated in unitary dual, and this is Meglan show that it's in Arthur packets. So in this way, she got unitarity. Okay, so what is interesting is that, okay, here this Arthur packet in one case, but all the 68 representations are also Arthur type representation. So we have theorem, let pi be an irreducible subquotient of nu to x1 row times nu to xn row times sigma with n less than or equal 3. Suppose pi is critical, then it is unitary if and only if it is Arthur type. Actually, now it's natural. Okay, okay. To think, to conjecture, is this true? For all n. Certainly, one, if it's at a type, then it is unitary. So what is interesting is this implication. So related to this is following conjecture. Each isolated unitary representation of classical group is critical. So I hope this, but so if both of these conjectures are true, then any isolated representation in unitary duals of classical groups would be Arthur type representations. Okay, I told something about unitarity at critical points. Now we would just a few remarks about non-unitarity. Actually, unitarity of isolated representations in unitary duals, it's hard to get. But somehow questions of non-unitarity is usually much harder. And I will just give idea how I proved non-unitarity of this, I think, 42 types of representations. Actually, this was either proved using, let's say, Hermitian families that you moved somehow. If you know that some things are connected with in the same Hermitian family, and you know for one, then you know for another that it's unitary or non-unitary. But the main way was the following. Let pi be an irreducible representation of classical group. And let tau be an irreducible unitary GL representation. Suppose length of tau cross pi is strictly greater than multiplicity of tau tensor pi in Jacquet module of tau cross pi. Now, Frobenius reciprocity tells you then tau times pi is not semi-simple. So in particular, pi is not unitary. Okay, so you have a very simple way of thinking, but just what is here complicated is just get, for example, a big length. The biggest length which I have obtained was 7, and actually it's sometimes there are very few examples where it's very easy to get this length. These representations, but usually it's hard, and all these things depends very much on geometric lemma, so all these computations. So I think I will now finish because I should already have finished some time ago, so sorry for extending. I will not write classification theorem in this corank 3. Erez Lapid formulated the theorem in a very nice and short way. Actually, he also rewrite my proof. Actually, I wrote a new proof. My proof was by, let's say, brutal force, and he gave a very nice geometric interpretation, picture of this, and in this geometric interpretation you have, let's say, 10 or 15, I do not remember, about 15 such drawings, and his proof actually has potential just to be extended to higher dimensions. There is, simply I do not have time, so, but there is a formulation of the generic dual and unramified unitary duals, and so there is another way how I would like to have this classification, which is very much connected with Arthur Packett's, but just actually I must stop here, and this will require additional lecture. Thank you very much, and sorry for taking your time.